9, we're going to talk about something called anti-differentiation. And the question is why? What is all this? So I could be given a derivative, like for example velocity, or let's say acceleration, which is the second derivative. But I could be given a derivative and I will be asked, find the function or family of functions with f prime as derivative, as first derivative. So now I'm going backwards, and you can say, how can you have the derivative if you don't have the function? It is possible. It is possible that I could be given the derivative, and I could be asked to find the function or a family of functions with that derivative. When we talk about family of functions with a particular derivative, we also call that the most general antiderivative. Okay. I could be given a function, and I could be asked, find uppercase f of x. And you can say, what's the difference? Well, when I'm given the derivative, I have to use the notation lowercase f of x. Of course, if this is g prime, then I will be using g of x. If this is t prime, then I will be using lowercase t of x. There is a difference between that scenario and this scenario. When we get to a later section in chapter 5, I will come back to this notation and explain again why we are using this, why we have this difference. So if I'm given a function, I can determine the antiderivative. Antiderivative. I could find a family of functions or a function whose derivative is this. Now, let's start with a very simple example. If I want to determine a function whose derivative is x squared, how do I go about that? What do I have to do? Well, simply I have to increase the power of x by 1 and divide by exactly the same number. Because when I differentiate this, I bring 3 in front, I simplify the 3, and I get x squared. So what could be the general rule? The general rule will be, if I need to obtain x to the nth power, then I have to have x to n plus first over the same identical number differentiated. Or in other words, if I want to find the antiderivative of, let's say, 3x cubed, I will say no problem. That will be 3x to the 4 over 4. If I put another constant here, then this becomes the most general, not just one antiderivative, the most general. There is a family of functions that have the same derivative, infinitely many. Constant, this is a constant, any constant you want. It could be from negative infinity to infinity. So this is an infinite number of, this scenario gives us an infinite number of functions whose derivative is that. And this is the most general antiderivative. So I'm on 6. So given, let's say, f of x equals 3x to the third, uppercase f of x will be 3x to the fourth over 4 plus a constant c, which is the most general antiderivative of 3x to the third. All these functions have the same derivative. I'd like to practice this concept. You can choose from your book if you'd like. I'll choose a couple in between, and you can choose from the end of 4.9.
Professor, I had a really quick question.
Any question, please. Yes?
So will they always want, like for the final answer, will it always want the most general
No,
antiderivative?
no. Very good question.
Okay.
Awesome. I'm going to get to examples right this moment.
Okay, thank you.
Thank you. So here's the first question. R of theta equals secant theta tangent theta minus 2e to theta. Since this is not a derivative, you can say, but it is, and I will have to agree, it is. Since I'm asked to find the most general antiderivative, find R of theta, the most general antiderivative. So R of theta will be, which function prime gives us this? Excellent, thank you, Derek. Minus 2, which function prime gives us this? The nicest functions of all. The nicest function.
E raised to theta.
Plus a constant c. Awesome. This is the most general antiderivative of this function. And now we go to other examples, like if you want to choose, feel free to. I'm going to choose this. We are given f double prime of x, the second derivative, as negative 2 plus 12x minus 12x squared. And we are told that f of 0 is 4. And we are also told that f prime of 0 is 12. This time, given these conditions, we are really asked to find the unique, there is no need to write the both, the function given the conditions. Above. This is the only function that complies with the given conditions. Okay. In order to determine the function, I have to go through the first derivative, and then I have to reach the function. I cannot jump from the second derivative to the function. That's not possible. Okay, so then my first step is to find f prime. So which function prime is negative 2? Which function I will differentiate to get negative 2?
Negative 2x.
Of course, very good, thank you. Plus 12. Which function prime is x?
6x squared.
So it's, yes, but I have to write it as x squared divided by 2, so everyone to see what is going on. Very good. Minus 12 times, which function prime is x squared? And that's x cubed divided by 3, plus a constant c. I will have to clean it up. So that is 7. So So f prime of x is negative 2x plus 6x squared minus 4x cubed plus a constant c indeed. Perfect. Now, I am given a piece of information, which is right here. I am told that f prime of 0 equals 12. What does that tell us when we are told that f of 0 is 12?
It's a critical number?
A critical number is when f prime is 0 or f prime is undefined. I'm given this information to help me find c. So f prime of 0, 0, 0, 0, which means c is 12. Very good. That's what it means. So f prime of x equals negative 2x plus 6x squared minus 4x cubed and plus 12. I'm going to write it in the correct order now. So f prime of x is negative 4x to the third plus 6x squared minus 2x and plus 12. So this is our intermediate step. Why intermediate step? Because I only accomplished this. I don't have this yet. Then this is what I'm after. And I'm also given a secondary condition. So now finally we can write the function. What function prime is x cubed? X to the 4 over 4 plus 6 x to the third over 3 minus 2 x squared over 2 plus 12x plus a constant d, not to be confused with c. Or I can use c1 and c2, whatever you want. It's the same thing. So then now f of x equals negative x to the fourth plus, I'm simplifying 2x cubed, I'm simplifying minus x squared plus 12x and plus d. Why is this information given to us? That f of 0, they say, equals 4. What do you think?
To find D.
Exactly. So what do we conclude from here? Is that d equals? That's it. Right, because 0, 0, 0, 0, d equals 4. Is that okay? Does everyone see this?
Yes.
Yes? Okay, perfect. So then f of x is negative x to the fourth plus 2x cubed minus x squared plus 12x and plus 4. And this is the only function that complies with the given conditions. What conditions? Has a second derivative that is this, and f of 0 is 4, and f prime of 0 is 12. And this is not the most general antiderivative. Any questions? Any questions?
And the f over here is lowercase, right?
The notation is lowercase because we were given f double prime.
When did you say the f is positive? Or f is capital?
That is when the given function is f, not f prime.
Thank you.
So when the given function is denoted to us, is given to us as in the notation of f of x, then we are determining uppercase f of x. This is for being consistent with the fundamental theorem of calculus that we will talk about in chapter 5. Other questions here? Okay, I would like to look at, if you want to choose, I'll be more than happy. So we're given an acceleration now as t squared minus 4t plus 6. And they're also telling us that s of 0 is 0 and s of 1 is 20. they're asking us to find S of t, the unique function of motion. Where is our starting